Hi everyone, and welcome back to another episode of Octopus Builds. My name is Bob Walker, and I am the Technical Director of Customer Success, and we are building the Trident project for the fictional company Octopet Shop. Now, in last week's episode, or last episode, depending on if you're binge streaming this for some reason, what we did is we added in the runbook to create the Trident database, as well as updated our deployment process to call the Octopus Deploy Runbook. I'm just going to call this Run Octopus Deploy Runbook. You know what? I'm going to call Quick Mulligan and say, let's say, run create Trident database. All right. Runbook step. This is more it's more of a favor to my future self before I forget anything. So what do we want to do today? What we want to do today is we want to deploy the database. So we have created the new database. Now let's deploy some changes to it. So what I've done is I have uploaded a new package called Trident.database up to my instance, and a link to that you can find in the description. And from here, what we want to do is we want to deploy this particular package to our database that we created in the previous episode. So let's go ahead and let's get started. First up, let's talk connection strings. So I'm going to grab a connection string off screen really quick, and let's jump over to here. So as you can see, let me expand out the connection string just a little bit. We have all kinds of information getting added in here. Now the thing is this is what this is actually what the connection string is going to be for our particular application. Now, a couple of things that you note, if the eagle eye amongst you will notice, is that we don't have the user ID and we don't have the password. Instead, what we're doing is we're using integrated security. That's a practice I would recommend doing. So running your if let's say an IIS app or any type of application, if you have the capability to run in a specific user on that server and then that user has limited permissions to the database, I highly recommend doing something like that as opposed to passing around database usernames and passwords all over the place. It ends up being, you end up having more security, especially if you're hosting things on, say, Windows, because you can leverage things like service accounts, and those passwords that you're then keeping into a smaller known cluster of people that have access to that. So, just less people know something, the more secure you are. So, and it also has a number of other benefits out there. So you can easily disable that account in case it becomes compromised, and then it loses access to everything. So, awesome. So what we need to do is we need to change our database a couple of things around, some of our variables. So what we want to do is let's go ahead, and I'm going to actually create a new variable called project.connection.string. And a big reason why I want to create it like this is just because that way it's easier for me to reference it, and I'm not referencing something I'm going to be replacing in my app settings. You don't have to do that. That's just me being just my OCD flares, and I can't help myself sometimes. Let's call it project.database.name. And what we want to do here is let's go ahead and let's replace this. So this is kind of a snake eating the tail, multiple layers of exception, whatever you want to call it. Now for my project database name, I want it to be Trident for production, but if you recall in the previous episode, we've installed everything it's going to be running on the same server, it's going to be running on the same worker. Again, this is just a proof of concept, it's a demonstration, whatever you want to call it. So I'm going to add another value because everything's going to be sharing the same server. But I'm going to call this Trident, and I'm going to underscore and then octopus.environment.name. And what I can do here is I'm going to scope this to multiple environments. So I'm going to scope it to dev, to QA, as well as staging. Awesome. I'm going to do a few other things. Now, I don't need to change this. I don't need this database project database server name because it's just local DB MS SQL local DB. Easy peasy. Don't need you. And I don't need the username anymore because I'm doing integrated security. So I'm cleaning up a few things here, so that's always nicer. Make this screen a little bit easier to read when I first come in here. Awesome. And let's just expand this out just so you can see what's going on over here. So what I've done here is I've now scoped a you can do this. You can scope the same variable to multiple environments. Another thing I could have done is just scope this to, say, production and not scope this to anything. That's certainly an option as well. It's really up to you as to how you want to do it. So I'm going to go ahead and click on Save for this one. All right, so we got all of the variables configured as we want. So now let's go into our process and make some changes. So let's add a run a script step. And the first thing that we're going to do is we want to make sure that we can generate a report so we know what's about to happen before the database changes actually occur. And so what we're going to do is we're going to generate delta report. Actually, I'm going to call it database delta report. Run once on a worker, hosted Windows. That's exactly what we want. And cool. So let's go ahead and I'm going to copy in the script that I have already written because I am lazy and I don't want to rewrite it in front of everyone. Only bad things will happen from that. Cool. So let's go ahead and let's add a package reference. So this is a new thing that I want to say new. It's relatively new in terms of the lifecycle of Octopus Deploy, but it was added when we added in workers, and that's the ability to reference packages from a script step, because this is a perfect use case for this when we are deploying a database, because you're not deploying directly to the database. What you're doing is you're actually extracting a package that contains a bunch of scripts that you're going to run over a specific connection to the database. So it's a lot like accessing, say, a server over a particular port or anything like that. Awesome. So I have done a couple things. Let's take a look at our script that we got. So I have my package path and Trident.database and my extracted path. And so what this is this is the path that the zip file, my package, my Trident.database package, is going to be extracted to. Then I have my environment name, which I really don't need anymore. Actually, what I want to have is, let's just have my database name, because that's truly what it's going to be. And let's add in project database name. Sweet. And in fact, I'm thinking about this. It's funny, I already wrote this script, but I'm already making changes to it to make it even more efficient. I really don't even need that database name. What I need to do is I just need to reference my connection string. So I'm just going to add my project.connection string. I can get rid of this. And then I'm going to have just a reports path. And what this is this is where I'm going to generate the report. The next thing that's going to happen, and don't worry about trying to copy paste this, all of this information you can find in the description or links to it in the description, so you don't have to worry about trying to handwrite anything. But what it's doing is it's grabbing the current location, which I don't really need to do. I'm changing the directory to the package path. I'm running it and providing the connection string, the preview, and then I'm going to generate an Octopus Deploy artifact from this. Perfect. So this is generating the report that we want to run. Next up, what we want to do is I'm going to clone this step. Actually, I need to save it before I clone it, which is fine. Next thing I'm going to do actually is I'm going to add a manual intervention step before I do that. So what I'm going to do here is I'm going to have approve database delta or delta script. Delta script found in the artifacts section. Okay, and I'm going to make the responsible teams DBAs. For manual interventions, what this does is this pauses the deployment while someone does some sort of action. So while they're approving the database delta script. Now, by default, you want to have probably 1 or 2 teams at most being responsible to this. So in our case, the DBAs. However, there might be a scenario where you have some sort of emergency fix or some sort of, things are down, you need to break glass type of scenario. So I always include, say, the Octopus managers or the Octopus administrators, because they have the power to pretty much do whatever they need to do. And so we don't want to have a situation, so they can, if they need to, they can also approve this manual intervention step. And we want to allow another, prevent other deployments. Well, yep, we want to, only one deployment will execute for any project environment combination. What this is going to do is, while we're waiting for someone to approve this, we're not going to have another deployment get triggered and allow that to process through. And for now, we want to run this in every environment. In the future, we probably might run this in, say, staging, or we might run this in production. But for right now, let's go ahead and let's just run this in for all environments so we can see what's going to happen. And now that we have the approve script, I'm not going to clone this. It's just a simple copy paste. What am I doing? I'm just going to copy paste this. I'm just going to add another step. And let's say I'm going to deploy the database changes. I actually haven't deployed the database changes. I've just generated the report. So I hope everything works. We're going to find out together. All right. We don't need the report path. We need to have that. We don't care about this. And we don't need to generate the report. So all we're going to do here is we're just going to extract the package, connect to the database, and run this package. What this is using a technology called dbup. And if you're not familiar with dbup, it is a free open source project, dbup, that you can use to deploy your database changes. It was originally written for SQL Server database changes. That's what it says right up there. But it has support for a whole host of database providers out there, not just SQL Server. I think, MySQL, Postgres, it has almost all of it that's up there. Supported databases. Hey. So SQL Server, SQL Azure, SQLite, SQL CE, MySQL, Postgres, and Firebird. So this is just a nice, handy tool. All it does is you include a series of scripts. So create tables, default feed settings, you include those scripts, and it will grab all of those scripts and it will run them basically once against your database. So this is a migration script approach system. It's fairly simple to use. It's free, which is why I like using it. And I do need to reference the package before I forget. Trident database. Go ahead and save it. And obviously I want to run this for all environments. No reason to skip over that. All right, let's reorder some steps. Generate, approve, and deploy. So let's talk about what I just did. Generally, you're going to want to deploy your database changes before you deploy your code changes. One of the nice things, again, about dbup is it runs everything in a transaction by default. So if it either all goes or none of it goes. And so if there's a problem, if there's an error, what will happen is that will basically roll back any database changes automatically, and it won't even try to deploy your code. Which is exactly what you want. You don't want to have your code out there if there's database change if it's expecting database changes that don't exist yet. So let's go ahead and commit this. Deployment steps. And awesome. One last thing before I forget is I want to make a small change to my process here. Install the SQL Server local DB. I want to have this reference the database name that's in our variables. Probably should change the SQL Server, but I'm not going to do that because I just don't feel like it right now. Awesome. Let's just make sure that's published. The latest changes are published. We've updated our snapshot. Variables are good to go. All right, let's go ahead and create a release, and let's cross our fingers and hopefully everything works. We're going to run it in our default channel, which is by default is dev. We have our packages, Trident database, as well as Trident web. It has the pre-release tag, which is what we expect, and I'm just going to add in I'm going to add in database deployments, just as a way for us to kind of know what's happening. Funsies, I guess, is what you want to call it. So let's go ahead and deploy. Alrighty, so hopefully everything is wired up and it's going to work how we want it to work, but we shall see. Let's fingers crossed for something like this. So let's talk a little bit about artifacts while we're waiting for this to kind of finish doing what it's going to be doing. What's going to happen with this generate database delta report is it's going to generate this HTML file that's going to contain all of the information that is about to be deployed. It's going to show you all the scripts that are about to be deployed, which is perfect, because then what we can do is we can pause the deployment and we can then have someone take a look at those and make sure that there's something that everything looks legit. Some common examples of why someone would want to manually approve this, especially at the beginning, is there's this fear that once you automate your database deployments like this, that someone could sneak in a step that does things like drops a table, which would be terrible. Dropping a table in SQL Server is the same as deleting a table. It's just a different nomenclature, but deleting a table. Or you could sneak in a script that could, say, add a user to as an admin on the database, and then it could just go in and do whatever the heck they wanted to do, something like that. So generally, to make sure that none of that's going to happen, this is a good way to kind of start building up trust in your deployment process. And ultimately, that's really the goal behind all of this, is we want to build trust in this deployment process so anyone feels comfortable in using it. And you'll start seeing the benefits of doing this, because once you start automating things, you're going to start removing a lot of the unnecessary human interaction, where they have to come in and they have to manually write scripts, or have to find the scripts in a directory and physically run those scripts. Any number of those things. It just kind of slows everything down, and we don't want any of that. With the whole point of automation is, especially around database deployments, that seems to be kind of the final frontier for doing any sort of deployments, as that final automation piece, so to speak, is getting the databases there just requires just more trust than anything. And that the big reason behind that is because databases are where you house the data, and they're very, very, very hard to roll back without losing any sort of data. It's no matter and a lot of times, depending on the database change, the best approach if you want to roll something back is actually to roll forward, just because there's that concern of data loss. And if you lose data, especially customer data, especially if you are a public-facing company, that could be a massive, massive loss in terms of the amount of data. If you're a site that gets millions of users a day, if you deploy something and you come up with this idea, oh, I need to roll something back, that's just not going to be a viable thing, especially if users have been in it for more than like a couple minutes. So let's take sorry, I've got my long rant about rollbacks and database deployments. Let's take a look what's going on over here. Why are you taking so friggin' long? Okay, you finished running. I just got to have a little patience, I guess. So we've made sure that the database has been installed, and the database has been created. The server's been installed, and now what we're doing is requiring the packages. So everything should be good to go here. So we're downloading the packages onto our workers. Happy days. And then now we can actually kind of get into the database delta report. You might be wondering, why is it taking so long? Most of this is just due to I let my dynamic worker go to sleep between recordings again. And so it had to wake itself back up, and apparently it was a little groggy getting everything back up and running. So hopefully now it should go a little bit faster. So we're extracting the package, which is exactly what we want. It has generated the Delta script. Awesome. So let's take a look. So we have the upgrade report. You can download this. And so now we can see all of the tables that, you can see all of the scripts that it's going to run, which is perfect. That's exactly what we wanted. Create sync log. Awesome. Those are all the tables we want to create. There's nothing in here that looks out of place. It's just a bunch of table creation where we're adding in some foreign keys, adding in making sure that we are forcing data integrity, exactly what we would expect to see. If I was a DBA, this would be something I'd be comfortable approving. I'm definitely comfortable approving it because I wrote it. So this is what a manual intervention looks like. So what we've done is we've paused it. I can then come in and I can assign this to me. And from here, let's go ahead and say, yep, it looks good to me. If I wanted to, I could download the artifact from over here. It looks like I'm missing the environment name. Oh yeah, I removed it from the script. I'll fix that off camera. Let's go ahead and proceed. The script that you'll be able to download will have all the appropriate bits and pieces. I was just editing after I wrote this script and I thought everything was working. I just made it harder on myself. Awesome. Now, one of the things to know about manual interventions is they do put, when a task is paused for the deployment, it could be paused for a few seconds for the manual intervention to finish. That's typically rare, all the way up to several hours. And so what happens is Octopus Deploy puts it basically back into the task queue, and then we have to wait for it to be picked back up. So that's why it has to reacquire those packages. So it should be extracting those packages now and running, and hopefully, fingers crossed, if I had everything working correctly, it will deploy and we will see those database changes. And it deployed and it worked. Happy days. This is great. Awesome. So what I'm actually going to do is I want to show you what the upgrade report would look like. Again, hopefully, I really want to know this actually. So I'm going to redeploy this to dev. And it should go a lot faster this time. So what's going to happen is I'm redeploying this, and what I want to do is I want to show you what the Delta report would look like if there are no database changes. And when there's no database changes, that's actually a good thing, because then maybe we can start looking at other things we can do to make your deployment process a little bit more robust and a little bit faster. Because again, it goes back to automation. So you're not having unnecessary steps just to have unnecessary steps. We want to make sure that it is as fast and as efficient as possible, while at the same time you're not you're following your process when you need to follow the process. But that's for a future episode. I don't need to go into that right now. Let's go ahead and make sure that that finished up correctly. That ran fairly fast. And requiring the packages. Awesome. Already has everything, and so we should be good to go. Generating the Delta report, and what we should see is that there is nothing in that database. Sorry, there's nothing to deploy because it's the same package, and we're just redeploying it. That is one of the advantages of DBUp, is that it does have that capability to go ahead and only run scripts that haven't been run yet. So let's go ahead and open this back up. Haha, there is a script in here, and this is a script that I added in, and this is configured to always run. And so what this is doing is it's always making sure that those, that this role in the database already has these permissions. So, but we don't see any of the other create tables or anything along those lines. So this is actually okay. This is exactly what I was expecting to see. So great. I can go ahead and assign this and again proceed. And that is, in a nutshell, how database deployments work, but as well as how to add in manual interventions so you can pause a deployment, review something, and then proceed on to the next steps. Now, if something didn't look right, if I saw something that didn't look right, I could abort the deployment. I could also just sit there and let it wait while, if I was, say, a DBA, I could go walk and talk to the developer going, hey, what's going on here? This script is looking a little crazy. Let's, did you mean to do something like this? Generally, you don't want to have that happen in production. Hopefully have it happen in, say, dev or test before it gets up to production. But we're providing a mechanism so you can do that and you can verify things. Now that's it for this week's episode. Thank you very much for watching, and have a great rest of your day.